Good morning. We are electronics engineering students of the National University of Colombia. This video tutorial is going to do a brief introduction of two neuroscience papers written by PhD Oscar Javier Abella González. This is the final project of the course Computational Neuroscience, Understanding and Modeling the Brain, that took place on January of 2015 under the 8th International Lecture of Engineering in the National University of Colombia in Bogotá. First of all, we are going to talk about the 2012 paper External Drive to Inhibitory Cells Induces Alternating Episodes of High and Low Amplitude Oscillations. This paper is 14 pages long and its model must be simulated on the simulation environment Neuron 6.0. So, in the main page of Neuron, we find that the last version is Neuron 7.3. Consequently, we have to go down and click on the link Prior Versions. There, we find all the prior versions of Neuron since it was released. We proceed to log to the 6.0 version, download, extract, and install it. You will notice that a version for every operating system is available, so you must choose the one that corresponds to you. In our case, we choose the one with the .exe extension that corresponds to Windows operating system. When you have the right version of Neuron installed, you should download the model that corresponds to the 2012 paper. To download this model, you should click on the item Auto Launch and the item Download zip file. Go to the folder where the model was downloaded and extract the .zip file. There you will find a folder named Main. In that folder, you must copy and paste the Auto Launch file and then open it with Neuron 6.0. Pay attention and type Y when it asks you run Neuron. Afterwards, more windows will be opened. There, you must modify the t-stop time to 40,000. This is in order to have the same run time that is specified on the paper. Then click on Single Run to start simulation. As the simulation finishes, two of the windows will show the result of this simulation. The model was designed to reproduce cortical oscillation, especially those occurring in the beta and gamma band of the frequency spectrum, as observed in the prefrontal cortex and hippocampus of rats and humans. This model consisted of a network of 80 excitatory cells and 20 inhibitory cells, connected with AMPA excitatory and GABA inhibitory synapses. The synaptic strength and connection probability was chosen so as to produce a strong ping-like pyramidal interneuron gamma rhythm. Neurons were modeled as single compartments, conductance-based cells with potassium, sodium, and lead channels, and the synaptic level inhibitory cells project GABA synapses, excitatory cells project AMPA synapses. This model will produce a .m file that can be opened with MATLAB software. This file is created in the folder Output MATLAB and it's named as waxingguanin.m. To run this example, you should open with MATLAB the file runexamplefig.m that is located on the main folder. The results of this example show a figure that corresponds to the image of figure 3 of the 2012 paper. This is a clear example depicting fluctuation in the amplitude of oscillation due to the change in synchrony between the cells, which is high during high amplitude excitatory and low during low amplitude excitatories. From top to bottom, the figure shows A. The rastergram of the excitatory cells, B. The fire rate histogram and the corresponding interpolated spline envelope. Finally, in the bottom panel, we plot C. The wavelet transform of the fire rate histogram, showing creep fluctuation in the power, amplitude of the oscillation for a frequency around 18 Hz.
Now we are going to talk about the 2004 paper Internetwork Interactions: Impact of connection between oscillatory neural network on oscillation frequency and parent. This is this paper is 16 pages long and it model must be simulated on the simulation environment Neuron 7.0. So we proceed as before, we don't and click on the prior versions, download, prior versions. There will log for 7.0 version. Download, extract and install it. Remember to choose the one that corresponds to your operating system. This is my operating system. Now we go installation the program. Double click. Yes. Next. Install. When you have the right version of Neuron installed, you should download the model that corresponds to 2014. This is the model. Download zip, download file, and download auto launch. Go to the folder where the model was downloaded and extract the file to zip file. Unzip. There you will find a folder named 2netspaper. 2netspaper. And inside is a folder called main. In that folder you must open the file called control execute network bgk.hoc. This is with Neuro 7. When you do that, a Windows will be opened. There, you must click on single run to start the simulation. The simulation will last between 3.2 and 12 hours, depending on the specification of your PC, of your computer. As the simulation finishes, four of the windows will show the results of the simulation. The model was created to study the possible effects on the oscillatory dynamics of a neural network, target network. Receiving feed-forward synaptic input from a second oscillatory network, source network. We simulated two non-harmonic oscillating networks, but consisting of a population of excitatory I cells and population of inhibitory E cells. The time of simulation was 40,000, and the time stone and millisecond are 40,000. This model will produce a.m file that can be opened with MATLAB software. This file is created in the folder output MATLAB and its name is GAI coin NA2AX4 read. To run this example you should open with MATLAB the file run example fig.m that is located in the main folder. In the results of this example, the top panel presents the Fourier transform on the slow network, and corresponding Weber transform during the time of simulation, and the bottom panels are the same for the fast network, in this case the target network. You can compare the figure with the D and A panels in Figure 9 of the 2004 paper. Thank you.